waiting a bit, so probably we start at 4:01 when everyone has joined. So let's do a quick sound check. Can you hear or see Graham, myself? Can you see the slides? Please type into the chat window.
Hey everyone.
Excellent. Thanks, Mark. Very good. Good. We still give it a minute or two. Here another person is joining. Good. It's 4:01. I think we start for today. Thanks everyone for joining the fourth webinar from AWS and COVID. Really glad to see everyone here. Thanks a lot, Graham, for joining us here. Fantastic to see that AWS is supporting us in this webinar series. So let's go to the next slide, please. So today we do have all about databases. So Graham from AWS will present us in the next 45 minutes all about AWS Databases. And the title of it is AWS Databases, Become Cloud Native, See the Portfolio and see it in action. So Graham will do most of the talking. So I will keep it short. But for those of you that have not heard who we are, Copit AG is an AWS Advanced Consulting Partner. We have been around for 5 years now. So our 5th birthday was about 3 weeks ago. We are an advanced AWS consulting partner, doing that since roughly 3 years. And we have been involved with AWS longer, and we do have a number of people highly certified with AWS. But we also do containers on AWS, but also on premises. So some banks and insurances, they still want to have their containers and Kubernetes environments on-prem. So we help these clients as well. And of course, we also do automation with Puppet, and that is mainly on-prem for those clients that still want it. And to round up that package, we also do cloud consulting and IoT, because our CEO is quite into IoT these days. In total, we are 15 employees spread over Zurich and St. Gallen, and we are here to help you driving any of these projects that you see listed here. Next slide, please.
So thanks a lot.
That's already handing over to Graham. Graham, the stage is yours. Thank you so much for joining us here today.
Thanks so much, and thanks for giving us the chance to talk here today. I will introduce myself in a second. First of all, a little bit about the agenda. So I'll let you know, a little bit about me and my background. Go over a few basics, which we won't go deep into, but we will assume, a bit of prior knowledge on databases. The name of this talk mentioned cloud native, so we'll just very quickly mention what cloud native means. There's many different definitions you can find on the internet, and everyone has a different opinion on what this means. We'll talk a bit about relational database offerings and then non-relational database offerings from Amazon Web Services. We'll talk a bit about strategy and how to really choose something that fits for your use case. We'll talk a little bit about migrations. So maybe you have some databases on your own infrastructure on-prem that you might want to move into AWS or migrate to something totally different, and a little bit of Q&A. So I would like, if we have time, to also show a few things in the console around the database service, but I think I will go through the slides first rather than ping-ponging between the slides and the console. It's a bit complicated with screen sharing. So please put any questions in the chat, and we will get to that towards the end of the talk today. So quickly about me, my name is Graham. I'm originally from UK and specifically Scotland, as you can maybe tell from my accent. I try to speak as clear as possible. but I've been here in Switzerland for almost 20 years. I have experience in quite a lot of different areas in my career. So I worked for many years in finance industry, which is very common for almost everyone been in Switzerland for a long time. I've worked in AV, audiovisual, with streaming video services. I worked in telecoms industry, and most recently before AWS in the education side of Switzerland with Switch, where I worked together with a lot of the universities, research institutions such as CERN, and also together with other countries with cross-European education initiatives for the cloud. I'm working at AWS since May 2020, so 1 year, 4 months or so, and I'm working in the solution architect team here in Zurich, and I'm working with some large customers, but also a lot of small startups, greenfield customers who are making their first steps with going into the cloud, and it's my job to be an advisor in the whole portfolio of products around AWS and doing concepts, prototypes with the customer, and helping them any way I can to get going on Amazon Web Services. So as I mentioned before we talked, I wanted to mention a few basics. Now, we could spend hours going into a lot of these terms, and the idea today is not really to go into database design and database basics, but just to mention quickly, we do have various concepts like structured data, which is what we imagine from, let's call it, traditional classic databases, where we have tables, we have a predefined structure, which we can call a schema. Usually we have rows and columns. We have primary keys and tables. We have foreign key relationships between tables and other tables to tie everything together with referential integrity. And then on the other end of the scale, we have unstructured data. So this is when we have no defined schema. We could even treat unstructured data as literally files lying around the file system. But we can span the whole range of these different data structures, and there are different solutions to these different problems. A couple of terms we will hear very often when we talk about databases is OLTP and OLAP. OLTP stands for online transactional processing. This is traditional transactional workloads. When we talk about transactions, we think of ACID compliance. ACID compliance, we can think of it as transactional based, meaning you perform certain actions in your database, perhaps insert updates over a certain amount of tables. While this update is taking place, perhaps there is a lock on those tables or a lock on the columns, and then once the transaction is finished, you can commit the transaction, and then this is written to the database. Or if there's an error, you can roll back the transaction. This is a bit more complicated than that, but this is the basis for ACID compliance for transactional processing databases. And otherwise, we have OLAP, which is online analytical processing. So this is more about, for example, data lakes and big data type of databases. Now, cloud native is in the title of the presentation, and as mentioned, there's many different definitions of what cloud native means. I took this definition from Wikipedia. So I think the key thing is utilizes cloud computing to build and run scalable applications in modern dynamic environments. We think of databases, we think about managed databases, we think of very easy scalability and high availability, usually in the hands of AWS rather than you. And we think of ease of use, efficiency, pay-as-you-go type of methodology. So when we think of cloud native, that is probably how we think of when we talk about databases. And things have changed a lot over the last 40 years. Modern applications have a brand new set of requirements, and these applications demand ever more performance, ever easier scalability, scaling to huge loads very quickly. And of course, one of the key things is extreme high availability of these databases. And of course, these things are massive challenges if you try to do it yourself. So if you have your own database system or on your own hardware and your own data center, there's so many things to think about, so many barriers to what you actually want to do, which is simply store your data and run your applications. So one thing that I didn't mention at the beginning is in my previous life, I was a database administrator in the finance industry. So I was administrating Sybase, Adaptive Server, SQL Server, PowerShell, Oracle. And my life was this column on the left-hand side. So call it self-managed databases when you run your databases on-prem. So query construction, query optimization, performing failovers, having all this high availability practices in place, doing tons of stuff with storage racks, doing patching, doing all sorts of maintenance. And I was routinely woken up in the middle of the night because I had to do all of these things. And let me tell you, it was very stressful, especially in the financial industry. So this is one of the reasons why we want to go to the cloud, because you can let AWS do all of this dirty work and let you concentrate on just the things you want to do. So on the right-hand side, we can see, as a customer, what do you want to do for your application? Design your schema, design your queries, put your data in there, and leave all these other things to AWS, all of the heavy lifting, all of the pain, giving you much more time to concentrate on what's actually more important for your business. It's a massive advantage if you can just forget all of these low-level, heavy lifting, monkey work stuff. So as mentioned, we wanted to give a bit of an overview of the portfolio on what is available on AWS. So we mentioned before relational, non-relational, and we will split this into two different sections today. So on the very left-hand side, you can see relational. So this is what we call classic databases, referential integrity with transactions. And in AWS, we have the Relational Database Service and Aurora. Actually, Aurora is part of RDS, but it's often listed separately. And everything to the right of relational is, let's call it Varia, or non-relational type of databases. So for example, DynamoDB is our extremely low latency, high throughput key value store database, which you can see here at the bottom is suited to a lot of real-time applications like shopping carts, product catalogs, or leaderboards for online gaming, that type of thing. Then we have DocumentDB, which is a database to store JSON documents based on MongoDB. Then we have Elasticache, which we won't talk about too much today, but this is when you would like to have ultra low latency access to your data. So Elasticache sits in front of your other types of databases, such as Aurora, RDS, and has an in-memory store for ultra low latency. And Elasticache is based on two engines, namely Memcached and Redis, which I'm sure some of you are aware of. Next, we have a graph database called Neptune. This is one of my favorites, so I hope to spend a little bit of time on this later and show some of this in the console. This takes the idea of data organization into a totally different realm. And this is ideally used for things like relationships, or relationships which are not always obvious at the time of designing a database, which usually they are not. So something like Neptune is used for things like social networks, fraud detection. Really, really cool thing. And quite a new one here is a TimeStream, which is a time series database. So collect and store metrics or data points organized by time, often used for things like IoT, event tracking, DevOps type applications. QLDB is a ledger database, so a verifiable record of entries into a database, which are stored in a ledger and can be cryptographically verified. We'll talk about that in a little bit. Finally, Keyspaces, so wide column database based on Cassandra. We won't really mention today. And there's one more thing on this list, which is brand new, is MemoryDB with Redis, and we will very, very briefly talk about that later. So first of all is the RDS service. This is the relational database engine from AWS. So we have various flavors. We have Aurora, MySQL, Postgres, MariaDB, SQL Server, and Oracle. They all work the same way, or they're all managed the same way on AWS. Security and compliance, availability and durability, and performance and scalability. So secure from the ground up, based on network security, access control from IAM users, data encryption built in using AWS KMS, or as you see here, also flavors from Oracle and Microsoft, strict compliance, and also Active Directory Kerberos integration. So we can secure the network for all RDS flavors through virtual private cloud. This is your private part of AWS, where you define your own network access. You can define your own ports and sources. You can define which server types you want to be below your RDS databases. So your RDS databases run on virtual machines, and you can define what type of virtual machines should be below this based on memory, CPU requirements, etc., etc. So there's always an option of instance type and also storage types depending on your database and your application. So as you can see here, we offer various types of SSD storage, your general purpose storage for most typical operations, but if your application is very high amount of IOPS, we have provisioned IOPS storage where you can define very large amounts of operations per second. So it gives you the choice of what you would need for your workload. Now, one of the biggest advantages is scaling. If you try to do this yourself on-prem, you will have to pre-provision tons of storage, tons of servers ahead of time so that you're ready in case you need more capacity for your database. Advantage of RDS is scaling can be extremely quick, can be automated. You don't have to worry about running out of space. So you can scale your compute capacity and also your storage, and also reduce these if your need goes down to save money. RDS allows multi-easy deployments. So in case you don't know, Amazon regions are split into availability zones, which are geographically separate, let's call it data centers. So of course we advise a database deployment to be over multiple availability zones. And a multi-easy deployment allows you to have a master instance in one availability zone where you perform reads and writes, and a standby instance in a different availability zone, which is ready to become active in a failover scenario. And this can all happen automated. One other thing is read replicas can be spun up with a couple of clicks. So maybe you have a primary instance for your read and write operations, but you might have a lot of applications that only need to perform reads, for example, reporting applications. So you can spin up a separate read replica instance from RDS and point these applications to a different endpoint in your database. This can also be done with one click. And needless to say, we have automated backups, which can be implemented with one click, with up to 35-day maximum retention. And that about covers RDS in a nutshell. Of course, it's much more complicated than that, but we have so much functionality built in as standard. And I will show a couple of things at the end when we look at the console. So Amazon Aurora is also part of RDS, but we usually treat this separately, as Aurora has been built from scratch for the cloud to be our, let's call it, go-to cloud-native database. So Aurora also supports two engines of MySQL and PostgreSQL. Aurora is slightly more expensive than the other MySQL and Postgres implementations. However, as we can see on the bottom, Aurora offers 3 times faster than Postgres and 5 times the performance of MySQL, and has lots of more additional better features for high availability and durability. this really is the one to go for. So Aurora decouples storage and query processing. So on RDS, query processing and storage is on the same instance. So if you have massive queries, this can impact your storage and vice versa. With Aurora, the storage layer is completely separated into a totally different area, meaning your querying and your storage doesn't impact each other. And with RDS, where transactions are written to a disk on the node and then asynchronously copied to the standby node, Aurora features an entirely new data layer behind the scenes, which performs extremely quick synchronous replication to enable much, much faster querying, much better disaster recovery, backup, read replica optimization compared to RDS. So as you can see here, it's purposely built functionality for the data layer, striping across data layer, many copies of your data over the availability zones, giving much higher durability and availability than the simple RDS service, allowing us to give you much more features. And I won't go into this, we don't have so much time, but it's a lot of advantages over the bare RDS service by using Aurora. Point-in-time recoveries, backtracking, regional scalability, etc., etc. Okay, so that's it for the relational side. Now we're going to talk a bit about the non-relational, or what we call NoSQL side. So a little bit of history, we can see here that, in the past, we were based with these monoliths like Oracle, DB2, SQL Server, all in the classic relational model. Then in the 90s, moved into things like Access, MySQL, PostgreSQL. And then recently, from around 2000, we've seen a lot of growth in, let's call it, specialized databases that differ from the relational model. And I don't think this is a coincidence. I think this is really the demand with modern applications, the demand for cloud, or the demand for specialized databases for specific functionality. So rather than trying to shoehorn your application into like a relational model, there's many other different models which are much better fitting for the use case. So now we have the choice, and of course, it's maybe not always so obvious on the choice, but this is why we're here to help you to negotiate this choice. And the reason why we have this is, yeah, in theory, relational databases look nice. We have tables, we have primary keys, we have foreign key relationships. It looks lovely, right? But the reality is something more like this. You have a massive spaghetti of tables. It's almost impossible to understand. Someone new in the team trying to learn your schema is extremely difficult. What happens if you want to add a new feature to your application? It is extremely complicated. So this is why we have the demand for these purpose-built NoSQL databases to allow you to do this complicated stuff, but in a very specialized and a much, much easier way. So the first one I wanted to mention is DynamoDB. Now, this is a very, very highly used database on AWS. It's our fastest and most flexible NoSQL database. Enables massive scale, as you can see here, millions of requests per second with single-digit millisecond latency. And these transactions or these updates can be mirrored to global regions of AWS. As usual, or not as usual, but in comparison to a lot of the RDS databases, where you still have your database running on virtual machines, DynamoDB is completely serverless. You don't have to think about provisioning instances, about storage scaling, about your compute scaling. This is all done 100% in the background without you having to touch anything. So just insert your data, read your data, everything else happens automatically. And although DynamoDB is NoSQL, it does feature ACID compliance. It does feature many cool features like encryption at rest, point-in-time backups, and a new NoSQL workbench. And as you can see here, single-digit millisecond latency at petabytes of scale. This is like biblical scale of data that you can read anything from in single-digit latency. So kind of trillions of items, petabytes of storage. Now, as mentioned, DynamoDB features a fairly new feature called global tables. So with other database flavors, it runs in like a single region of AWS, and potentially you can have a read replica in other availability zones or read replica in another region, but often, usually the writes are in one specific region to one specific instance. DynamoDB allows writes for this global table feature in multiple regions around the world. So this gives you multi-region redundancy, and as you can see here on the right-hand side, multi-active writes from any region. It's like a massive thing to implement, and such a useful thing for many of our customers and many of their applications. And finally, I mentioned before Elasticache. Elasticache is a caching engine for many types of databases, typically relational databases. DynamoDB has its own root cache called DAX, which takes you to even microsecond latency for specific applications. Next, moving on to DocumentDB. So DocumentDB is a fully managed MongoDB compatible database. So DynamoDB can and does store documents and can be used for storing documents, but it's not its primary function. So DocumentDB's primary function, of course, is storing JSON documents. And the architecture is based around the same architecture as Aurora. So for example, the same type of data storage layer, the same read replica functionality, again, fully managed, and you can see here, compatibility with MongoDB 3.6 and 4.0. You can use the exactly same SDKs, you can use the same tooling, which you might have directly to MongoDB, which should work pretty seamlessly with DocumentDB on AWS. And of course, the benefit is you have a lot of integrations with other services on AWS to make your life easier around monitoring, logging, and application development. And yes, document data is used for many use cases, such as content management, mobile applications, user profiles from gaming, retail and marketing use cases. And as you probably know, MongoDB is in the world the #1 NoSQL database engine at the moment. And as mentioned before, as the same architecture as Aurora, the same separate storage layer, allowing us to give extremely high performance in a cloud-native way. And as already mentioned, compatibility with MongoDB 4, 3.6, use all the same tools, all the same drivers as you already have with MongoDB. So the next one I want to mention is Amazon TimeStream. So time series data is being used more and more with monitoring applications such as Prometheus, Grafana, with IoT, with DevOps monitoring. And time series data is, as it sounds, is a sequence of data among time intervals for events which change over time. Time series data might be a microsecond, millisecond, per second, per minute, but typically you will have a long list of data points for the same item that changes over time. And of course, this you can do also in other databases, but with a lot more effort and without built-in functionality of specific time series databases. And I already mentioned this, some specific use cases which are often paired with time series databases, such as IoT, DevOps, and app analytics type of applications. And I won't mention all the features here, but you can imagine, you might have data points of 1 millisecond, and you want access to these data points for maybe 1 day. But after 1 day, you don't care about this millisecond accuracy. And TimeStream has built-in features where you can roll up data points to provide an average or a single data point for maybe a day or an hour. So you can keep a history with less exact data points, but for the near history, then you will keep keep those exact data points. So all these types of built-in features where if you were using a different database engine, such as DynamoDB, you would have to perform these type of redistributions and calculations yourself in the application. And here, a typical workflow of something that could be done with IoT, bringing data in from your IoT device through something like AWS IoT Greengrass, or maybe your own bit of code written in Lambda. Bring this into, for example, IoT Core, which is the AWS IoT family of services where you connect your devices. Then these data points can be written into Amazon TimeStream. Then after this, your data points can be accessed from reporting. For example, QuickSight is a business intelligence tool. You might want to provide real-time graphs over time from your data points, maybe like a temperature sensor or something on your IoT device. Or you can put this data into machine learning applications or Grafana dashboards or anywhere else you like. Moving on to Amazon QLDB. Now, this is another interesting type of database, which is fairly new. I think it's been around for a couple of years now. This is a fully managed ledger database, which maintains a complete and verifiable history of changes over time. So what are the characteristics of a ledger database? It is immutable. So once something is in there, it stays in there. So as we can see here, it's an append-only immutable journey. So it tracks the entire history of changes. You can think of a ledger database as more or less like a transaction log from a relational database. But whereas a transaction log is usually kept for backup purposes or restore purposes, with QLDB, this transaction log or ledger is the database. It is verifiable. All changes are cryptographically chainly verifiable. So, of course, when we talk about ledger database, we think of things like Bitcoin network or Ethereum network that has a ledger for all these transactions. The difference between QLDB and one of these networks is that QLDB is centralized. So whereas a Bitcoin network is decentralized, where there's no central records stored somewhere, or everyone has the entire ledger, with QLDB, the ledger is still stored in one place on AWS, but can still be used for the same type of applications. Like many of our other offerings, QLDB is serverless and has some APIs such as PartiQL and Ion for data modeling and to give like a familiar SQL type of experience. So as mentioned, the journal is the database. But to make things easier, QLDB does come with like a database type structure as well. So what happens is writes will come to the journal, as you can see in the bottom. So writes or updates. And then behind the scenes, QLDB will write these values into a set of tables to allow us to query much easier. So you can see the top table here shows the current value of the owner of this Tesla. The committee table gives us the metadata of this row, including the block address. And then the history table shows us all of the historical records of this record. So you can see here there's two records and the owner has changed from one person to the other. And as mentioned, yeah, cryptographic verification. I won't go into this right now, but it is possible, and that forms the basis of the database. And some of the use cases of QLDB is useful for example, auditing, having an order of records to your business information, transactional system of records, for example, common use cases like cars or driving license information. When a car is passed from one owner to the other, something like a ledger, it would be a great fit for such an application like this. Now on to one of my favorites. We'll try to speed up a little bit. Neptune is a graph database. So a graph database is a database where we want to talk about relationships between data, right? Relationships between disparate things. So when we think of relationships, we think about social media. When you go to Facebook and click a like button, how is this done under the hood? As I said, graphs model data based on relationships and explores connections between sometimes on the surface disconnected pieces of data. So when you go to the Amazon website and you see some recommendations, this is most likely coming from a graph database behind the scenes. You say someone you know knows someone who also bought this PlayStation game or something. That is usually derived from a graph database. So a little bit of terminology quickly. So vertices or nodes are the main part of the graph database. So for example, a person with a name, some metadata like an age. And then in between those nodes, you have the edges or relationships. So the relationship might be one person is related to someone else, or one person likes something else. And you have directions. And that's about it, really. And as mentioned, common business applications that use graphs, social networking, that is a classic example. So relationships of relationships of relationships, recommendations, as I also mentioned, knowledge graphs of fraud detection. So for example, maybe you try to use a credit card in some other country and your bank might send you an SMS to say we blocked your card because we think this is not following typical patterns. So we think your card has been stolen. Behind the scenes, there's probably a graph database, something like Neptune behind the scenes. And this gives an example of a typical graph application based on knowledge graph. So a person lives somewhere, is related to someone else, likes something else, or as a hobby. And why do we want this? You can imagine building something similar on the left-hand side with a relational database. So human resources data, relational versus graph. So quite simple at this level. On the right-hand side, we see how it'd be done in Neptune. And you can see this is how it would be queried. So this time it's easy. Select star from employees, relational model, or this is in Gremlin query language from Neptune. This is how we would list the employees from that side. But what about having a reorg? Employees can belong to multiple groups, right? So now we have to add another table and two tables to match these relationships, split it out with new columns, column alterations. On the right-hand side, all we need to add is one new relationship. You can see here in green. Now you can see on the left how the query is now extremely complicated. On a relational model, on a graph database, it's pretty simple. Nested groups, so a group above groups. So we've had to add another table on the left-hand side, more rows, more columns. On the right-hand side, we just add a new node and two new relationships, right? Very, very easy. Queries get more complicated and stays pretty easy with the graph database language. I'm going a bit faster here. You get the message. So that was Neptune. So there's a few databases we didn't have time to go deeper into today. So I just wanted to mention them again. So Elasticache is a in-memory caching service, which is based on two engines of Redis and Memcached. And this is something you put in front of your other type of database to perform in-memory caching for very high read performance of your database. We could spend a lot of time on this, but I just wanted to mention it briefly. This is brand new, is a bit confusing, but whereas Elasticache is intended as a cache, MemoryDB for Redis is a full Redis implementation. So having Redis as a standalone database rather than having it as a cache in front of others. So this is something brand new. And we have Amazon Key Spaces, which is Amazon's implementation of Cassandra. That's also something which is getting a lot of traction. And one last thing I wanted to mention for database types is Athena. And Athena is not a database, but it's a query service. And it's really cool. How it works is you might have, for example, log data in text or CSV data from your applications. You might have gigabytes of these files lying on your file system in an S3 bucket. And Athena allows you to perform SQL queries on your CSV files, basically. So you can perform ad hoc queries to find out, for example, what is going on in your log files. And it's very, very, very cool way of avoiding trailing through logs and application data. And finally here, a part of this talk was about how we choose, right? There's many factors we have to consider for how we choose one of those models, which we talked about before, and what is the best fit for your application. So first of all, am I migrating from something else, or am I building something new? What are my access patterns? So what users will be accessing my data? What data do I need to extract for my application? Is it read patterns? Is it write patterns? What are my compliance requirements based on security? Always something to consider when choosing a database option. What are my backup DR requirements? Do I want to have multi-region database? Do I want to have my database in single region, but backups to, for example, another region for disaster recovery purposes? Do you want a provisioned or serverless model? So some of our databases, you have to select which type of instances you want, and other databases you can have fully serverless. You don't even have to think about this. And for example, do I have current tools? Do I have current APIs? Are my applications built with specific languages that should be compatible with my database option? And there's two mantras basically, which I always say to customers is, the first one is work backwards. Don't choose a database because it sounds cool or has good functionality just because you want to learn it or just because you want to use it. You have to think, what is my business application? What is my business need? What are the things I have to consider before choosing, right? And then once you have those things in mind, then you can look to find a fit of what database fits my purposes. And mantra two, choose a DB that is purposely built for your app, for what your app is designed to do. So do not try to shoehorn relationship graph type of applications into a traditional relational model, because although it can be done, it will be a lot of hassle and will give you a lot of pain, and there's for sure a better way of giving your application the best database it needs. And of course, you can always speak to Copebit or ourselves at AWS for help with these choices. And quickly before I finish, yeah, regarding migrations, we have many drivers. For example, your hardware can be end of life. We find scalability extremely difficult. Cost optimization. So when you have databases in AWS, you just pay for what you use. You can switch off your database, you can delete it, you don't pay another cent, right? You haven't bought all these servers in advance and are forced to think, I've got to use all this hardware, otherwise it's a waste of money, right? If you want to try database, you can just provision the database within a few seconds. You can use it, you can play around, you can destroy it again after a couple of hours and you won't pay another cent, right? Really leads to innovation, really leads to agility in your choice. To help you, we have some migration tooling. So we have a schema conversion tool, which can convert schema stored procedures between different database types. And we have a database migration service to migrate or replicate your data from on-prem into AWS or from a different flavor AWS to another. Let's get this one. So a couple of use cases. So you might want to migrate, right? So migrate one database into the same database on AWS or into a different flavor. But you might also want to replicate. You might want to keep your on-premises database, but push the data from database into AWS for some kind of analytics or for backups or for data lake. So although it's called database migration service, it can be used simply for replicating data using change block tracking from one place to another as part of the solution. And I won't go into this, but this details a little bit about how to replicate your data from on-prem data center into DMS using replication instance, define your schema, syncing your data. And as I mentioned, we can have homogeneous or heterogeneous migrations, so Oracle on-prem to Oracle in AWS or SQL Server to Aurora. So changing the database engine with code changes and stored procedure changes. kind of fan-out architecture, so we can put our data into different services using DNS, so maybe a database service, maybe into a storage bucket, maybe into a data warehouse, a database. And this is an overview of all the supported types, sources and targets. So sources on the top-hand side, and all of these can be migrated to targets on the bottom side. It's not a one-click service. All of these migrations have to be worked through. Often the best way of going about it is a mix of the data-specific tools, for example, MySQL dump, together with our tools like SCT and DMS. So it's not a one-click solution, but it makes your life a lot easier for doing these type of migrations. So Marco, I think I used up a lot of time. I think we probably run out of time for doing doing the console, and I think would be good to have some time for some closing and questions. So
Yes,
I will move over to you, and maybe you can come in here.
Yes, thank you so much, Graham, for the presentation. That is excellent. Thank you so much. So there is a question from Mark, and I read it out. You mentioned it and showed that GraphDB will be a good choice for social network. Do you think this is true in general, or are there well-known social networks where you will say GraphDB will not work, or another DB would fit better?
So, I mean, it's a good question. I mean, there has been social networks around for a long time, probably before there was such a thing as graph databases. So, I mean, it is potentially doable to build these in a different way. It is possible, but with, of course, much more maintenance, of your schema. And I think if you were building anything like this now, you would go straight towards something like Neptune or other graphing type of technology. And Neptune I didn't really mention, but it's built on Apache standards like a Gremlin, Tinkerpop, and a couple of other standards. This gives you so much easy functionality for mapping your data and visualizing your data and doing these things in, you don't even have to plan your schema up front, right? It can really evolve over time, and the whole idea is that it does evolve, right? And over time, there's many more relationships, there's many more nodes, and you don't have to keep track of this in tables, you don't have to expand tables, you don't have to update tables, and it would probably be bonkers to try and do this in any other way than using a graph database type of application. And I have to say that this to me is quite new. I've really been getting into this the last few months and playing around with it. I'd heard about graph databases before, but didn't really know what it was used for. And I come to realize it's actually very heavily used, not just for social media, but fraud detection and knowledge graph type of things, which are really hard to model in other ways. So I think it would be possible. I don't know what other guys are using, like Facebook and these type of sites, but I'm sure they must be using something very similar to Neptune.
Okay, cool. Thank you for that. A question from my side to expand on it. So I assume that graph databases are using GraphQL as a language. Is that very difficult to learn, or is it similar to SQL?
So there's a couple of options. On Neptune is GraphQL, and you have Gremlin, Tinkerpop, which is two different engines which can be used in Neptune, and two different query languages. So the GraphQL, Gremlin I find much easier. This is the one I showed in the slides. So whereas GraphQL is a little bit more obtuse. I think it's like maybe the difference between YAML and JSON, right? So it just takes a little bit of getting used to. But querying graph databases is a little bit, it's something a little bit new, right? And you have to get your head around it a little bit with how the data is structured and how to query. So, where do you start at a node, and how many levels in the graph do you want to go to query relationships? And you can go forward in the graph and backwards in the graph, and there's a little bit to learn. And there are some very nice workshops on the AWS website on the Neptune page of getting started. And I didn't have time to show you, but on the Neptune service, this comes with like Jupyter notebooks that steps you through how to to build the graph database and how to query using both query languages step by step to learn. And it also gives you visualizations, so you can input your data and you can visualize it and have a visualization of your nodes and relationships. So I would recommend doing something like this to get your head around, because it is something a little bit different from most other databases, and it's a bit difficult to understand at the beginning, but once you get going, it's pretty easy and it's extremely powerful, and that's why I think it's probably one of my favorite ones to talk about now from AWS.
Excellent. Cool. Thank you for that. Good. So then there is another question from Phil in regards of migration. Is there a migration tool that can migrate IoT data from DynamoDB to time series DB?
So DMS can be. I'd have to check if TimeStream is a target for the DMS. There are other migration possibilities. So you can connect, for example, DynamoDB with a DynamoDB stream or Lambda function to stream this data into like a Kinesis messaging stream and perform then, if needed, like a change in your data as it goes between DynamoDB and TimeStream and insert it into TimeStream. So I don't know if this is functionality of the DMS service yet, but for sure we have methods of moving the data. And actually I do have a customer which is considering doing this, that has been storing IoT data in DynamoDB, which can certainly be done, but you don't have the specific time series functionality like I mentioned in the presentation of smoothing the data after a certain time period, moving the dimensional data of maybe 1 millisecond after 1 day, rolling this up into data points of 1 hour, right? So in DynamoDB, you would have to do this functionality yourself, whereas in TimeStream, this comes as part of the product. So I do have a couple of customers that are thinking about doing this exact thing. So there are methods, and as always, please feel free to get in touch with us if you need any more information or hints and tips on any of these things.
Oh, excellent. Good. Then I have a question from my side. You mentioned a document DB, and
Yes.
I have worked in the past with clients that had quite some large MongoDB instances, and they looked at migrating that over to document DB and found that the starting price of document DB is quite high. So is that still the case? That's probably around 2 or 3 years ago.
It's kind of hard. It's kind of hard to comment, right? The prices generally do go down over time, so the service becomes more efficient. We introduce new instance types below, like document DB, so getting more performance either for the same price or cheaper price, and more efficiencies. As I said, document DB is built on the same kind of storage layer as Aurora. So when I mentioned about Aurora, it's a little bit more expensive than MySQL or Postgres flavors in RDS, but you have like 3 or 5 times the performance. And document DB, I can't really comment on the performance and the price exactly, but I think it's something that I would have to take offline to see what your costs are and what document DB costs are. And often you're can be comparing apples and oranges, right?
Because, yeah, of course.
You know, with document DB, a lot of this management stuff is done for you. Whereas if you're running it yourself, you have to spend a huge amount of time doing the management and patching and all this stuff, right? So that's why it's sometimes difficult to compare one-to-one, but no problem. You can take this up afterwards and feel free to contact me and we can talk about these points.
It's fine. That's totally fine. Cool. Good. Yeah, I think that's it. We are actually already a bit over time. So thank you so much again, Graham, for doing this presentation. It was really valuable. So thanks as well to the audience for being part of this. And as always, if you have any need with AWS or databases or containers or anything like that, reach out to us at hello@codebit.ch. Next slide, please. That's a thank you. And again, the next one, please. Good. And actually, that was the last webinar in that AWS Skills series that we did, but we are not over. So we are doing more more events, more webinars. And the next event that is happening is on the 5th of October. So we do have another container day where you have the opportunity to get exposed the full day with AWS EKS and ECS and see Kubernetes on AWS in action. You will have hands-on opportunity. So if you want to join, please register at the link that is shown there. Code AWS Container 3. That eventbrite.ch is free of charge. Come and join us. There are quite a few people registered already. Good, and that's already it. Thank you so much for being here. It was great. Thanks again, Graham, for doing the presentation. Thanks again for the audience. I wish you a great evening. Talk soon, and goodbye. Thank you.
Thank you.